Welcome to my YouTube channel. So today I'll make a short video on the stability. Okay, stability of a equilibrium point or stability of a dynamical system. So first of all, consider a non-linear dynamical system. Okay, x dot equal to f of x, where this x belongs to Rn. That means this x is x1 dot dot xn type component. That means this is look like x1 dot equal to f of x1 dot dot xn. This one f1 xn dot dot xn dot equal to fn function of x1 dot dot xn. So this is a n-dimensional non-linear dynamical system. For this, the equilibrium point will be defined by x dot equal to 0, or you can say x1 dot equal to 0, x2 dot equal to 0, or xn dot equal to 0, or you can find here f1 equal to 0, f2 equal to 0 dot dot fn equal to 0. All f1 f2 fn are function of x1 x2 dot xn. Okay, from this we can find a equilibrium point x equal to x bar. This is generally a n-dimensional equilibrium point. Now we discuss the stability. What is called stability? This system x dot equal to f of x. This is system number 1. Okay. Definition. Stability. So this is generally mathematical definition. The equilibrium x equal to x bar is said to be stable if for every epsilon greater than 0 there exists delta greater than 0 such that if the initial condition, that is x0, or initial condition x0 is within a distance delta from x bar, that is modulus of x0 minus x bar is less than delta. So whenever the initial conditions chosen in such a way that the difference between these two is very small, then any solution or trajectory which is denoted as xt is remain within a distance epsilon from x bar, that is modulus xt minus x bar less than epsilon for all t greater equal to 0. Okay. So let us see definition. So this equilibrium is said to be stable if for every epsilon greater than 0 there exists delta greater than 0, such that if the initial condition x0 is chosen such that this, then any solution xt will satisfy this condition. So if I discuss this geometrically, let us take this is x bar point. Okay, if you choose initial condition from this such that the modulus of these 2 points is delta, then the solution trajectory will converge to this point. Okay, that is, this is solution trajectory xt. So this solution trajectory will converge to this equilibrium point. If this happens, then the equilibrium point x equal to x bar is called stable. And if this equilibrium point of this system is stable, then this dynamical system also called stable dynamical system. Let's see asymptotic stability. What is asymptotic stability? Asymptotic or asymptotically stable. Asymptotic stability. Let us take A of the equilibrium point x bar is called asymptotically stable if it is stable. If it is stable and if there exists a constant b, obviously greater than 0, such that if we choose a initial condition x0 such that this less than b, then we get modulus xt minus x bar limit t tends to infinity equal to 0. This is limit t tends to infinity xt equal to x bar. So this equilibrium point is called asymptotically stable. If it's stable, first condition, it should be stable, and the second one is there exists a constant which is positive, such that if we choose initial condition in such a way that x0 minus x bar less than b, that is close to this in a small region of the equilibrium point, then the solution state, any solution state, will converge to this equilibrium point as time goes to infinity. A equilibrium point, this is the definition of asymptotic stability. Equilibrium point x bar is asymptotic stable if for any initial condition x0 in a certain region around x0. So if this x0, then in a certain region, if the initial condition is chosen, then the solution x2 will satisfy this one. As time goes to infinity, solution will approach to x bar. This means that as time goes to infinity, the state of the system xt gets arbitrarily close to this equilibrium point or to this state. So this is the asymptotic stable, and whenever this equilibrium point of this system is asymptotic stable, then the dynamical system also called asymptotically stable. Also, in other way, you can say if this is the equilibrium point x bar, this equilibrium point x bar is called asymptotically stable if all the solution trajectory close to this equilibrium point arbitrarily approaches to this equilibrium point. Okay. So an equilibrium point x bar is said to be asymptotically stable if all the trajectories close to this equilibrium point converge to this equilibrium point. So then this point we call asymptotic stable. Asymptotically stable, how we say that dynamical system is asymptotically stable or a equilibrium point of a dynamical system is asymptotically stable. So first, if this system, then you have to find Jacobian matrix. If D of f of this at this point x equal to x1, so this is Jacobian matrix. Jacobian matrix means in this system x1 dot equal to f of x1 x2, x2 dot equal to f1, sorry, this f and this is g, x1 x2. Then for this system Jacobian matrix will be first one del f del x1 del f del x2, and second row will be del g del x1 del g del x2. This will be Jacobian matrix, and at the equilibrium point, so this will look like x1 x1, so this will be equilibrium point for this 2D system, dynamical system. So this will be Jacobian matrix. This equilibrium point will call asymptotically stable if the eigenvalues of this Jacobian matrix evaluated at this point has negative real eigenvalues or complex eigenvalues with the negative real parts. If this happens, then we say this equilibrium point is asymptotically stable. All eigenvalues of the Jacobian matrix should be negative or with negative real parts. For today, that's it. I just discussed stability, asymptotic stability, and also there is exponential stability. There is three types of stability. First one was Lyapunov stability. Lyapunov stability. Second one is this asymptotic stability. And third one is exponential stability. Exponential stability means this equilibrium point will be called exponentially stable if we choose initial condition close to this equilibrium point, then the rate of approaching this equilibrium point or the rate of convergence of this solution trajectories to this equilibrium point will be exponential. What will be exponential? The rate of convergence. If I choose initial condition x0 and the solution trajectory xt, then this xt converges to x bar exponential. Okay, the rate of convergence will be exponential. So that is the types of stability. So for today, that's it. If you like it, please subscribe to our channel, and it will be very beneficial to understand the stability characteristics of a dynamical system. I was in a doubt about this stability, that's why I studied I studied the definition of stability briefly, and I think that you should also know. So thank you for that. Keep watching my videos and keep learning. Thank you very much. And if you really like it, please share with your friends. Thank you.